In this lecture video, I am going to introduce you to the second chapter of Module 4, that is Software Evolution. Through this chapter, we are going to talk about the introduction to evolution and why is it so important, the different processes of evolution, program evolution dynamics, software maintenance, and legacy system management. In this lecture or video, I'm going to introduce you to the evolution process and what is the need for evolution, and we are also going to learn why evolution is important and necessary to maintain software. Software development, as you know, does not stop when a system is delivered, but continues through the lifetime of the system. Now, after the system has been deployed, it is inevitably going to change if it has to remain useful. Business changes to users' expectations will always generate new requirements for the existing software or the deployed software. Now, parts of the software may also have to be modified to correct errors that were found during operation in the user's environment. You have to adapt it to changes in the hardware and software platform to improve performance and other non-functional characteristics. This is why software systems tend to evolve continuously. Software evolution is important because organizations have invested large amounts of money in building the software or in funding for the software and are now completely dependent on these software systems. Their systems are critical business assets and they have to invest in system change to maintain the value of these assets. Consequently, most large companies spend more on maintaining existing systems than funding new systems for development. Surveys also suggest that about two-thirds of software costs are evolution costs. For sure, the costs of software change are a large part of the IT budget for all companies. Now, software evolution, as I already told you, may be triggered by changing business requirements or by reports of software defects or by changes to other systems in the software system's environment. Therefore, the evolution of a system can rarely be considered in isolation. Changes to the environment lead to system change that may then trigger further environmental changes. Of course, the fact that systems have to evolve in a system-rich environment often increases the difficulties and the costs of evolution. As well as understanding and analyzing an impact of a proposed change on the system itself, you may also have to assess how this may affect other systems in the operational environment. Useful software systems usually have a very long lifetime. Consider a large military or infrastructure system, such as traffic control system, where you have to use these control systems to control air traffic. So these systems may have a lifetime of 30 years or more. Business systems are often more than 10 years old. Software costs a lot of money, so a company has to use a software system for many years to get a return on the investment they have made in developing the software. Obviously, the requirements of the installed systems change as the business and the environment changes. Therefore, new releases of the system incorporating changes and updates are usually created at regular intervals. You should therefore think of software engineering as a spiral process with requirements, design, implementation, and testing going throughout the lifeline of the system. And this spiral process is illustrated on the diagram on the left side of the slide. You start by creating release 1 of the system, which is a spiral. Once delivered, changes are proposed to the first spiral, and this leads to the development of release 2, which starts almost immediately. In fact, the need for evolution may become obvious even before the system is deployed, so that later releases of the software may be under development before the current version has been released. This model of software evolution implies that a single organization is responsible for both the initial software development and the evolution of the software. Most packaged software products are developed using this approach. For customized software, a slightly different approach may be used. A software company develops the software for a customer, and the customer's own development staff then take over the system, evolve, and maintain it. They are responsible for software evolution. Alternatively, the software customer might issue a separate contract to a different company for system support and evolution. So, this is about why system softwares evolve and why it is required to maintain a software or support software evolution. An alternate view of software evolution life cycle is shown at the bottom of the slide. In this model, we distinguish between evolution and servicing. Evolution is the phase in which significant changes to the software architecture and functionality has to be made. Servicing, on the other hand, we do only the changes that are made relatively small and essential, but they are not major changes. During evolution, the software is used successfully and there is a constant stream of proposed requirement changes. However, as the software is modified, its structure tends to degrade and changes become more and more expensive. This often happens after a few years of use when other environmental changes, such as hardware, operating systems, are also required to change. At some stage in the life cycle, the software will reach a transition point where significant changes implementing new requirements becomes less and less cost effective. At that stage, the software moves from evolution to servicing. During the servicing phase, the software is still useful and used, but only small tactical changes are made to it. No major changes to architectures happen now. During this stage, the company is usually considering how the software can be replaced. And in the final stage, the phase out stage, the software may still be used, but no further changes, absolutely no changes will be implemented. Users have to work around any problems that they discover during this phase. So, this is a brief introduction to software evolution. In the next lecture videos, we're going to learn about the various evolution processes in detail.